Welcome to the second half of our MySQL lecture. This in the second half, the first half we talked about the insert, update, select, and delete commands, the basic SQL capabilities. Now we're going to talk about some of the contracts that we're making with the database, having to do with the types of fields that we can store. We saw varchar 128 in that previous lecture. So we're going to talk about the various kind of text fields, various kind of binary fields, numeric fields, date time fields, and then fields that we do things like our special auto increment. And so when we start talking about strings, it's important to realize that there are two kinds of strings. String fields understand character sets, so if you have oriental characters that are more complex to store, these char fields and varchars are actual characters, and so they can have a Korean name in them or something like that. Char is a fixed length field that allocates all the space. It's a tiny bit faster for smaller strings that are very consistent, where they're pretty much going to be filled up all the time. They're known, and so char. Varchar is more common because they allocate a little bit of space for how long they are, but then they only use the amount of space that's used. So if you do like char 10,000, every row is going to have 10,000 characters taken up. So varchar is pretty common. Char and varchar can be indexed and used for lookups, like when you log in with your email and it wants to look your email up and it wants to index that, so it's really fast. So you tend to put something that's going to be taken from the user in a varchar field. Then there are text fields, and text fields are generally for paragraphs, textual information, because there's lots of times in databases we store pages of stuff. Not pages and pages so much, but like a single page, like in one of these little text input areas you see in various systems where you got a little bold and italics. All that turns into one blob of text. And so these are larger, they're variable length, and they're generally not used to do sorting or indexing or looking up. And there's sort of tiny text, medium text, and long text. I tend to really mostly use the text one for fields. I don't even make large varchar fields much anymore. If I'm not going to use them as an index, I tend to just call them text and be done with it. I don't think there's a real efficiency problem, at least in the modern versions of MySQL, to just use text for lots of things. There are these binary types that are actual 8-bit chunks of space, and they have no awareness of character sets, so you can't store anything other than 256-bit, 0 through 256 in each one of these 8-bit bytes. So they go up to and so there's a fixed and a variable length, but this is seldom used, but they're there, so you might see those. Now, you can also store large binary objects, and this would be a image, a JPEG image, or a GIF image, or a PDF, or a QuickTime, something like that. You can store these in databases. You tend to find that you don't want to store objects that are too large in databases. You tend to find a place to store them on the file system and serve them out of the file system. And so you tend to only use these things, 2 to 5 meg. You can go on Stack Overflow and say, when should I use a blob and when should I store it on disk, and it'll tell you that sometimes. And so real small things, so 2 megabytes. Like if you're uploading images and you can limit them to 2 megabytes, it's not bad. But the problem, if you make too much data in blobs, then you end up with backup problems. So you can't back your whole system up. The advantage is if you put it in the database, you back the database up and all your images are backed up. If you start putting really large files in, then your database backup gets really large, and so you don't want that. So it's sort of this balancing act as to whether or not you use blob. But the database is perfectly happy of putting a whole QuickTime file, 200 megabyte file in it. It stores it reasonably efficiently, but then it takes responsibility for making backups of those things for you. Integer numbers, very much the kind of thing that you want to do. Lots of things that we do are integers, and integers are very, very efficient. They take up very little data. They're quick to compare. They're quick to sort, all kinds of things. And there are a number of different integer sizes. There is tiny ints, which are sometimes useful for variables that you know are going to have some 0 through 10 or something like that, but that's about all they're good for. Integer is the common thing that's used a lot, and then really large integers can be done with Bigand. Floating point numbers can be stored, and these are stored in standard floating point in 32-bit or 64-bit. And the 32-bit numbers tend to have 7 digits of accuracy, and the doubles, the 64-bit numbers, have 14 digits of accuracy. So that doesn't matter how many, the number of digits of accuracy is like that, because these are all represented as a power. And so there's not a lot of call for it unless you're doing kind of scientific data, but it's right there. But very little of what we'll do in this class will use float. We're going to use a lot of dates. So there are timestamps. So one of the interesting things is timestamps. Timestamps are actually represented as a number, as an integer number of seconds since 1970. If you look at the number 0, that's 1970. January 1st, something 1970. And then it's like a second is added. Now it turns out that this may overflow depending on how big you make it. It might overflow and we'll have a Y2K problem in 2037. But these are very efficient. They take up very little space. They sort wonderfully, and you can sort of look things up very, very nicely with timestamps, and it's a per second resolution. And so that's good. There's time, there's date, and then there is date time as well. And these are all different features, and there's a built-in MySQL function called now that allows you to, in an insert statement, say, you know, this particular field, just put the current time in because MySQL knows what time it is. Auto increment is a very important feature. When we get to the later lecture on database design, we will need these keys, these primary keys that are sort of the way we can most rapidly look up a particular row. And so we'll tend to add a special key field, like for this users field, we will have a user underscore ID, and it's going to be an unsigned integer. Not null is a thing that says it can't be empty. And auto increment says, look, we're not going to actually tell you what numbers to put in here. You just, every time a new record gets added, you just automatically increment it, and then the rest of the thing. So this auto increment says to the database, it's supposed to maintain the field. So let me show you a little example of that auto increment. Let me take this create table here. So I'm going to go into PHP, go home, go to databases. I am going to get rid of my people database by clicking here and dropping it. So if I do a refresh, and then home and databases, people is gone now, and I'm going to do a new create database. Using this command. So hit go. Oh, I've got to be in a database. Oh, I killed my database. Now I got to create database people again. So go back to SQL, create database people. I didn't mean to get rid of it. I should have just dropped the table. That'll teach me a lesson. So now if I go back to databases, I've got my people database. And now I can create a table. Table I wanted to create called users. Say go. So there we go. So if I take a look at the database, I've got one table called users. And if I look at the structure of that, it's got 3 columns. One is a user ID, name. These 2 are from before, but this one has auto increment. So let me show you what happens here in the SQL. Let me go back and insert some statements way from the very beginning. Way from the very beginning. Redo some of those insert statements with auto increment this time. Here are my insert statements. I'll insert in here. Now you'll notice, oops, paste the right way. I have 2 columns. There are 3 columns in this database now. And I have only 2 columns specified, and I have Chuck and c7 at umich.edu. And that's because the 3rd column I have specified is supposed to be done automatically by the database. So I type go and I do a browse. And so now I can see this row. This number was assigned by the database because that's my auto increment field. So Chuck c7 at umich.edu. So I can go back in this SQL now and I can stick another thing, and I'll stick Sally in. Insert Sally. Again, no user ID. And I go back, and now there are 2 records. It's pretty predictable. It starts at 1, goes 1, 2, 3, 4, 5. Now I'll put these other 3 in, and you'll see it just assigns these numbers. Oh, actually, no. I'm going to go over here and use people show tables, make sure I'm in the right spot. Yes, I am. And now I'm going to run, oh, I should have put a semicolon on that. It's probably going to blow up. Yep. I need to put a semicolon on all of them. That's okay. I'll do them one at a time. I'll do them one at a time. Copy, insert, semicolon. You see it's putting in 1 row at a time. Copy, insert, semicolon. Now I can say select star from users to see what's in there. And so you see in this that the user ID for the first 2 I inserted using PHPMyAdmin is 1 and 2, and then 3, 4, and 5 were these inserts that I did in this command line user interface. And if I go back here and I hit the browse again, you'll see these are gone. Again, I'm just reemphasizing that this database administrator is talking to the database in one way or another way, and the application could be talking all at the same time. These are not this is not the database, and this is not the database. The database is a thing that we're all talking to, sending SQL commands to. So they're all sending commands to that same system. So this is auto increment, right? And we'll figure out why we need to do this. But the point there is that I can create this field by marking it auto increment. I'm saying, you take care of everything. I'm not going to do anything. I'm not going to come up with these numbers. I just want a number for each row. You know, sometimes it's not as perfect as 1, 2, 3. It's just give me a unique number for each row. So there's a whole series of MySQL functions. We'll run into these when we need them. The one we've mentioned so far is now, where you can put now in as a value instead of like having to put the current date in quotes. If you just mean right this minute, you put now in the SQL query. Another aspect of creating these tables and setting up these contracts, this is what's called indexes. And so everything we've done so far is like five lines or 5 rows, so it's really really fast. And it's reading the whole thing, and we don't even notice that. But at the end of the day, if you had 100 million users and you were going to 100 million user records, and you were going to look it up by email, you would want to be able to just make an index so it can jump in more quickly. And so there are techniques to shorten this lookup, so you don't have to go through the whole thing. And the 2 techniques are called hashes and trees. And so in MySQL, you can give it a couple of different index types. One is a primary key index, and that's what those auto increment folks are. They're very little fast. They're exact match lookups, good for numbers. They're really fast. And then there is the kind of classic index, which is I'm indexing a character field where I might do the entire match or a subset of a prefix of it, or I might sort it. And so it has to have a sense of what's nearby one another. So these indexes also help sorting. The order by work well. Full text is sort of like a search engine, and it's kind of a tweaky little creepy thing all by itself. Not a lot of applications use full text search because there are significant costs every time you insert something, and so it's used in highly specialized situations. So we'll use the primary key all the time for usually those auto increment fields, and then index for character fields that we're going to do lookups on or sorts regularly. So the 2 techniques we use for lookups, and this is pretty much the primary key index is good for this, and that's called hashing. And a hash function takes as input large chunk of data and then runs a calculation to produce something smaller. And so the hash function is, you can go read up on hash functions, the various kinds of them. And what we do is, instead of taking a long string, we reduce it down to a number. But the problem is that hashes might have collisions, right? So John Smith, when we run it through this function, might end up with 2, and then Lisa Smith will end up with 1, and then Sam Doe ends up with 4. But if we run Sandra D through, we'll end up with 2. And so we have to deal with what's called collisions. But when you do it, this can be very long and this can be very short. And it's a very efficient way to sort of not have to look to make the lookup table be based on these smaller numbers rather than make a lookup table based on these numbers. Now the key to hashes is they do not maintain order, right? And so that's why in, say, a Python dictionary, which is exactly a hash, it doesn't maintain order for you, even though that's counterintuitive. And that's because it's storing them and indexing them and looking them up in this very fast manner using hashing. Now, the other way to do this is when you need to have a sense of order. And so you could think of these as little spaces on disk, right? So we're going to look for, let's say, 10. And what this is these are chunks of disk that it reads in, or maybe chunks of memory, but let's just pretend they're chunks of disk. And if you're going to read the whole thing, it'd be costly. But you read the first one in, and then you have, in effect, this is telling you ranges. Right? When you look at this 7 and 16, that says go to this other place on disk if it's below 7. If it is between 7 and 16, go to this place in disk, and if it's above 16, go to this place. And so if we're looking at 10, 10 comes in here, and it doesn't have to read all the way through, cha-cha-cha-cha-cha. And it can go straight to here, and then it reads through this, and then it finds 10 doesn't exist. But and so this is basically, instead of reading all the way from the beginning, and the key thing is this, there could be literally hundreds of these, right? And you could skip 50 easily and go right to the thing that you need. And then sometimes there's 3 levels of trees, and there's all kind of tricks to make these trees. But the basic idea is it saves us from doing sequential reading by, we can read and then skip just to the part we want and then read what we want. And so given that the sequential reading could be very, very long, and the skipping is like 2 reads versus however many we have to point where we get to our stuff. Okay, so that's called a Btree index. And now what happens here, of course, is this actually then, the 12 points to some other area on disk, which is the actual data. So it reads here, and it goes there, versus, you know, reading all the way through here and then having to go to there. Okay, so, and when new records are inserted, like if we were to insert 10, well, let's insert 13 because it's easier to draw. It would look for where 13 goes. It would put 13 somewhere on disk, and then it would put it in here, and then it would add it to this 13, and then point 13 to that little bit of disk. Now at some point, if it had to do a 3, the 3 would come in here, and then it would have to break this in half and put and make 2 little blocks and fiddle around up here. So sometimes these have to be reorganized. So there is some cost when you're inserting data into one of these B-trees, but it's beautiful because you can do super quick lookups, and you can make things come out in sorted order very nicely and very easily. And so if we want to add an index, we can either add the index at moment of table creation. So here was our previous table where we're saying da 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 da, and we're saying index name. So that just says, that's a contract that says, I'm going to use this name as a lookup, or I might sort on this name. So I want you to create these extra data structures so that sorting and lookup is really fast on name. And by not mentioning that on email, I'm just saying, look, if I happen to sort on email, I know it's going to take longer. But if you can possibly waste a little bit of disk space with one of these indexes, you can save me some time, because I'm communicating to you my use of this name might be different than my use of email. You can also, if you already have a table, you can add an index. And this is often when we're in the middle of a system and the system's slowing down, like, oh wow, it's slowing down. Oh, let's go add an index and see if that helps. So I'll just add the index to the table that I've already got. It's not too exciting. It works. So I'll go in here, I'll go to the SQL. Now, at the moment that I'm adding this index, it actually reads the whole table and makes all the index and puts all the pointers and makes it all work just nice. We don't care about all that detail. We just go, and it's done. We don't even really see much different, but all we know is that if we sorted by name, it's faster. Now, of course, there's only 5 records, so it sort of hardly matters in this particular case. That just means this sort of name is faster than this sort of email. But it's meaningless because everything is fast. Oh, wait, bring that back down. So that's an index. And so this second half, we actually, in the first half of this lecture, we learned how the basic language works. And the second half, we learned how we can sort of begin to establish contracts with our database system as to how these columns work and whether we're going to sort them and different things. And this is just the beginning. There are many more details, but we've hit the high points of the creation of database tables and that kind of thing. So see you in the next lecture.